Hello, ladies and gentlemen, welcome back. That's a whole lot of topics up there on the screen, but what we're going to be doing is going to be continuing our work through pre-algebra goal 1. And specifically, we've been dealing with some of the basics of addition and subtraction, and now we're going to start moving on. We want to add to that skill set. We're going to first start with some basic mixing and matching, but then after that, we're going to be moving into fractions, which I know is everyone's favorite subject. And this is where I'm a math teacher, because fractions are actually legitimately, without irony, some of my favorite things. They're easier to do in my head than decimals, I'll tell you that. Anyway, we'll get over some fraction basics, make sure everyone's on the same page, and then we're going to talk a little bit about adding and subtracting fractions. And I'm also going to talk about some buttons on the calculator. Theoretically, if we get there, we'll see. So, to begin, we're going to go back to finishing up what we were talking about in terms of mixing and matching. We had just learned about adding and subtracting integers. Integers, again, being the fancy math word for positive and negative numbers. So now we get into some stuff that's more than just doing one or the other. Because now we have 3 integers, and there's that pesky word again, meaning we're dealing with positive and negative numbers. What I like to do is you want to kind of group your same sign stuff first. I'm doing too many things, hang on. Same sign stuff first. Once you group, and I do that specifically because, like I said in the last video, you're going to be adding those, and people tend to be better adders than they are subtractors. So, looking at this first problem, I look at the 7 and the 3. I can see that they're both negative, which means I'm going to add them, and it becomes 10, and the negative drops down. Negative 10 plus 2, that, I'll remind you, is the opposite sign. Opposite signs mean you subtract. 10 minus 2 is 8. What's the bigger number? The 10, so the sign drops down. Over here, what do we have? We have the 7 and the 5. Those are the same signs, so again, we're going to add. That becomes 12, and then the result of that is the negative drops down plus 4. Opposite signs we subtract. What's 12 minus 4? 8. And what's the bigger number? The 12. So therefore my answer is negative. We got the same number again. Oh, don't tell me that's going to happen like it did in the last video. Over here, those are the ones that are the same sign. 1 plus 2 is, of course, 3. And now we have opposite signs, so we're going to subtract. What's 8 minus 3? 5. And then what number is the bigger number? The 8, and so it drops down. Over here, 3 and 7 are the same sign. And so therefore we're going to add them up in order to get 10, and the negative drops down. What's 1 minus 10? That's going to get you 9. 10 is the bigger number, so that's the sign that dominates. And you can do that on into perpetuity. Like, you can just keep going over and over and over again. And whenever you see me doing math live in front of a smartboard or a whiteboard, that's exactly what I'm doing, is I'm grouping my similar signed objects numbers first, and then I'm combining them after the fact, and I find that basically easier. But that's about it for the fancy mix and match stuff. I thought there was more. We'll catch it later. Now we want to talk about equivalent fractions. So let's see here. Fill in the blank to make 2 fractions equivalent. This one is relatively straightforward again because it's an introductory topic. 7 times what gets you 21? That's times 3. So 5 times what? 5 times 3. And what is 5 times 3? 15. That's our answer. When I'm looking over here, 9 times what is 45? That's times 5. And what I do to the bottom, I do to the top, times 5. 4 times 5 gets me 20. That's what equivalent fractions are doing. Now, for this one right here, simplifying a fraction, there's actually a button for this on the calculator, and that's what I wanted to talk about for these couple of topics. On your calculator, you might have to find it, but you're going to find a button that looks like this. It's called the ABC button. And then above it, usually in some kind of like light blue or maybe a yellow or something, you are going to say I think it looks like A, B, C, and then it's going to be an arrow to D, E, something like that. I forget the exact combination, but this is the more important of the two. This is your fraction button on a calculator, and this will help you with quite a few of this math. But I don't have the calculator, or at least I don't have a version of it that I can be emulated on my computer, so we're going to do this the long way. When I'm looking at simplest form, ultimately what I'm doing is I'm looking for a number that both the numerator and the denominator can be divided by. So for example, 9 can be divided by 3, honestly, and I think that's the only number. 15 has a couple of numbers that it's divided by, 3 and 5. 3 is the one they have in common, so that's what we're going to divide by. What's 9 divided by 3? 3. What's 15 divided by 3? That does not look like a 3. Try that again. 9 divided by 3? 3. What is 15 divided by 3? 5. And that's going to become your answer. Over here, 5 is only really divisible by 5. Is 15 divided by 5? Yes. So what's 5 divided by 5? 1. What's 15 divided by 5? 3. Then for simplest form for 10 and 15, 10 has 2 and 5, 15 has 3 and 5. Obviously the 5s have it because they're the ones that are in both the numerator and the denominator. Ergo, 10 divided by 5 is 2. 15 divided by 5 is 3. 4 and 14, let's see here. 4, you have 2 and 4. 14, you have 2 and 7. Obviously the 2s have it because those are the ones that match. 4 divided by 2 is 2. 14 divided by 2 is 7. That is simplifying fractions. And now we're going to, that's the introduction, that's doing it for the really smaller fractions. Now we get to the slightly more nuanced ones. And we have a mistake here that we'll talk about later, which I totally didn't do. What are you talking about? That was absolutely something else. Let's do 42 over 48. I'll like that one in a second. So 7 only divides one way. That can be divided by 7. So what is 42 divided by 7? Can that be done? Check it on the calculator. Yes. 7 divided by 7 is 1. 42 divided by 7 is 6. Now, looking at this one, 42 and 48 respectively have actually quite a few that they're divisible by. Knowing that they're close to each other, I'm going to pick some of my middling numbers. So I know 42 is 6 times 7. Let's see here. It is probably 3 times 14, and I don't really want to go further than that. If I have to, I will. 48 is 6 times 8. That's good. It's also 3 times 16. Are there any others? I don't immediately see it. But when I'm looking at my factors, the 6s are what they have in common. So 42 divided by 6 is 7. 48 divided by 6 is 8, and we got lucky on our first try. Now, some kids have a little trouble kind of seeing that, so I do want to show you an even longer way, because the one thing to notice is that 42 and 48 are both even numbers, so I can divide by 2 and divide by 2. That will get me 21 over 24. Now, that might be a little bit harder, but I can kind of tell that's divisible by 3, and 24 is divisible by 3. And that also will get me the 7/8. I don't care how long it takes for you to get to your simplest fraction. If you're the type of person who has to reduce it several times, that's fine. Even Ms. Dubois, as good as I am at doing fractions in my head, sometimes I have to simplify it multiple times because I won't necessarily notice it. Let's see here, 36 and 45. I know that this is divisible by 6, but the 45 isn't. So what else is 36 divisible by? It's divisible by 12, but 45 isn't, so that won't work. It's not divisible. 45 isn't divisible. Oh, no, I should be looking at the 45. Did you miss that? Okay, 45 is the easier number to look at because there's fewer factors for 45. It's 5 times 9, and I think it's like 3 times 15, and that's it. 36 is only pairable with one of those. Two of those. We can pair with the 3 because 36 divided by 3 is 12, but it's also paired with the 9. When it happens, because that's going to be 3 times 12 and then 4 times 5. So there's the match. So we know these are out because they don't actually match. When I have two options, I have both the 3 and the 9, always pick the bigger option because that will simplify it more. So 36 divided by 9 is 4. 45 divided by 9 is 5. And then there is my fraction. All right. And now we're going to go into, oh, look, signs. We get to deal with those pesky integers again. So the thing to talk about and to remember is that a double negative nets you a positive. So I'm looking at that first one right there. I see the negative there and a negative there. Double negative is a positive, so the equivalent to this is positive 7/10, which means there's only one of these that checks off. Now over here, there's only the one negative. So I'm tracing my way through this and looking for anything that has only one negative. So that one doesn't have any negatives. That one has two negatives. That's way too much. This has only one negative, and this has only one negative. And that's how I go through to check them. This one you can see has only one negative, so I'm tracing my way for only one negatives. That doesn't have one negative. That doesn't have one negative. That one does, and that one does. And it's worth mentioning, negative 7 over 6 equals 7 over negative 6 equals negative 7 over 6. They all mean the same thing. And because they mean the same thing, all of these things are interchangeable. Through sheer convention in mathematics, we're going to put the negative in front of the entire fraction. But the computer, generally speaking, especially in Algebra 1 and Algebra 2, they're not going to care quite that much. They're going to have a little bit of freedom here. And then for this last one, that's positive, and it's worth remembering, double negatives get me a positive. Where is my double negative? Where is my double negative? There, right there. And that's the box that you're going to check off. So now we're going to deal a little bit more about mixed numbers. So we're plotting, okay, boo, the number lines didn't, fly on you, screen grab. All right, so we have 1, 2, 5, 7. All right, I'm going to place, this is going to be annoying, 1 and then halfway is 2, and now let's make this really thin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was a little bit hard to do, but let's pretend that that works. So if you're looking at your spaces and you're plotting, there's a difference between a space and what I'm going to call a notch. So when you're looking at the number line, this is your space, and then the lines that are little tick marks, those we're going to call a notch. Notch, I can spell, there we go. So if we're looking at 2 and 7/10, we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. That's exactly correct. We want to make it 7/10, so we're going 7 notches in. So in other words, these are your spaces, and these are your notches. So I'm going over 1, 2, 3, 4, 5, 6. There's my notch number 7, so that's where I'm going to be plotting my number. Now for 2/5, you'll notice that this is cut into 10 spaces, not 5. So 5 times what gets me 10? So that instead now becomes 1 4/10. That's a lot easier. And now since I know that there's 10 spaces, I'm going to move in 4 notches. So 1, 2, 3, 4, that's the space where I'm going to be plotting my numbers. And that's what you're going to be doing throughout all of this. So this one, we have the 1, we have the, nope, we have the 2, and then we have the 3. Now get my thing super small. We're looking for 9 notches. So 1, 2, 3, 4, 5, 6, 7. Nope, did not give myself enough space. Boo. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There we go. So 1 7/9, we're going to count 1, 2, 3, 4, 5, 6, 7 notches. For 2 2/3, we need to make that a 9, so we're going to multiply that by 3, so we're going 6 notches in. 1, 2, 3, 4, 5, 6. That's how we're plotting our numbers. Over here, curse you, screen grab. We have the 1, we have the 2, we have the 3, and we're going in spaces of 9 again. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's see here, 2/3. That's going to be, again, so 2 2/3. We need to make it 9, which means we're multiplying by 3, so we're looking at 6 notches in. 1, 2, 3, 4, 5, 6. So there's my 2 2/3. And then 1 5/9, that's going to be 5 notches in. So 1, 2, 3, 4, 5. There's going to be my point. So this was a little bit harder because they didn't give us the schnitzel number line, but I hope that that makes sense. Now, LCD, That stands for least common denominator, so the two things are interchangeable. What we're looking to do is we're looking at 4 and 6. That's what a denominator is. It's the bottom of your fraction, and we're looking at their multiples. So for the multiples of 4, we have 4, 8, 12, 16, 20, 24, and if I've run out of space. If I need to keep going, I will. What are my common denominators for 6? We have 6, 12, 18, 24, yada, yada, yada. Now you'll notice there is two numbers immediately that they have in common. 24 looks good, but we also have 12. And the thing about an LCD, your least common denominator, is that it tells you at a glance immediately what it's looking for. What's the smaller of these two things they have in common? The 12. If I'm looking at 8 and 20, yeah, I know what that's going to be. Looking at 20, 40, 60, 80, yeah, sure, but then you have 8, 16, 24, 32, and up, 40. That's what they have in common, so 40 is going to be your least common denominator. It's hard for me to sort of go through this in the sense that my human calculator brain can kind of just find this instantaneously, and I have to make myself slow down and make sure that I'm going through this technically correct so that you understand that. Now, the infamous fraction operations. Let's go through this. We have numerators, we have denominators. The important part here is that we have the same denominators. When you have the same denominators, there's no fancy steps here. The computer is nice to you. You don't have to do any hard work. So the question now becomes, what's 3 minus 1? 2. And then the denominator stays fixed. Over here, same thing. You have the same denominator, so we don't really care about denominators. We're more interested in the numerators. What is 6 minus 1? 5. And the denominator is just chilling there in the bottom, just doing its thing and vibing. Over here, I'm not even going to bother. I'm going to jump right to the denominator and copy and paste it. And same thing over here, because I know what the answer is going to be. And now the last step is what's 2 minus 1? 1. What's 4 minus 1? 3. It's when you have different denominators that you have expected to do extra work, and we'll talk about that in a little bit. Next, let's see here. We have signed fraction subtraction, so we're still just having subtraction, but look at that, double negatives. I'll remind you, I'm not even looking down at the problems yet. Double negation, if you have a double negative, that gets you a positive. So I can already see my glasses are going to come off. I'm going to look at that, and that looks like a plus sign because a double negative is a positive. A double negative is a positive. A double negative is a positive. And me just doing that visually makes it a little bit easier for myself. Now let's rewrite this. And here we do have, if you'll notice, we have different denominators. So now we have to do a tiny modicum of work. And now we're going to use these two topics jointly, because we need to find the LCD and we're going to use it to do our addition and subtraction. So I'm looking at 9 and 2, and I'm going to shortcut a little. No, I'll do the workout. We have 9, 18, 27, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's the first number they have in common, so that's what we're going to use. So 9 times what is 18? Times 2. Times 2. So that becomes 4 over 18. Plus, because we already know that that's double negation, which means addition. 2 times what got me the 18? 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 9 times 9. 1 times 9 is 9, and then that's an 18. And now look at this. We already know the denominator is going to be fixed. I'm not even going to look at it. We have opposite signs, which means we're subtracting. 9 minus 4 is 5. 9 is the bigger number. What's the sign? Positive, so our answer is positive 5/18. Same thing again. Now we're looking at our common denominators for 8 and 12. So 8, 16, 24, 32. I already know what the answer is going to be. For 12, we have 12 and then 24. So I've already found my least common denominator. So whatever my operations are going to be over 24. Now, 8 times what is 24? 3. So what's 3 times 3? 9. 2 times what gets me 24? 2. So what's 7 times 2? 14. These are opposite signs. So opposite signs mean you subtract. What is 14 minus 9? 5. What's my biggest number? 14. And what's the sign that dominates? Positive. So this is going to be positive 24. Over here, let's see here. 2 and 9. Oh, we did that over here. We already know what the common denominator is going to be. It's going to be 18 plus 18, and then that's a negative. So that becomes times 9 times 9. 1 times 9 is 9. That's times 2 times 2. So we have 2 times 2 is 4. And now what's my final answer going to be? These are opposite signs, so we're going to subtract. 9 minus 4 is 5. 9 is my bigger number, so what's the sign that dominates? The negative, and my answer is negative 5 over 18. Next, word problem. Oh no, the horror, the horror. I hear you guys freaking out. Word problem involving addition or subtraction of fractions with different denominators. The horror. Except honestly, what we're doing is exactly this topic. It's just that we happen to have words in it. So the big thing, again, is going to be keywords. We talked about this, I think, in the prior video, or maybe it was an Algebra 1 video. I've made so many of these, I've lost track. You walk 1/5 of a mile to a clothing store. You walk another 1/4 of a mile to a music store. So if you're walking another, that's kind of your keyword for addition. So you're doing 1/5 plus 1/4. And again, because you have the advent of the ABC button on your calculator, you can do this in a calculator, but I don't have that, so we're going to do this the long way. Now, let's see here. I'm going to shortcut a little bit here. I've gone through the effort of showing you all of the shortcuts here, and you've been doing this for several years in middle school, so now doing this in high school, I can theoretically afford to shorthand this a little bit. And if you're lost, talk to me in class. I will make it a little bit easier for you. My common denominator here is going to be 20. I can quickly do that in my head. 5 times 4 gets me 20, and then 5 times 4 gets me 20. And what is 4 plus 5? 9 over 20. Now you have finished a history assignment in 1/3 of an hour. That's 20 minutes. He has completed the chemistry assignment in half an hour. Okay, what is the total? Total is your keyword. That means addition. So we're doing 1/3 plus 1/2. Common denominator here is going to be 6. So 3 times what gets me 6? 2. 2 times what gets me 6? 3. And then either of those numbers times 1 are themselves. What is 2 plus 3? 5. 6. So it took 15 minutes to do the homework. Finished his assignment in 1/5 of an hour, so 12 minutes. Then he completed assignment in 2/3 of an hour. What is the total? Total again means addition. So we have 1/5 plus 2/3. What's our common denominator? It's going to be 15. I know that. So 3 times 1 is going to get me 3. 5 times 2 is going to get me 10. So that's going to be 13 out of 15 is our answer. So far, so good. Oh, that's the end of the video. Oh, happy surprise! Or sad surprise, I'm not sure which. I'll assume happy. Okay, so that is all of the topics. Look at that. We did three bunches of topics. 1, 2, 3, all in rapid succession. We did a lot of work with fractions and fraction basics. Our next big subsection for goal 1 is going to be decimals, and then, of course, using decimals with addition and subtraction. We'll talk about that more in the next video. Thank you for all of your hard work. Stay happy, stay healthy, stay safe, and I will see you in the next one. End transmission.